Flack math! Give me some math and I'll give you some flack. Flack math!
So just a reminder, not a reminder, I haven't even told you yet, but practice test and test. This is another test week, so do your practice test by Thursday for 5 points extra credit. It's always a nice little perk, and it helps you prepare for your test. So practice before I go over every question, and it's better for you, okay? So do that, and then we just have problem set 70, and then test 16. So let's get into this. So the next thing we're going to talk about is simplifying complex numbers. Now, what they decided to do is they decided, I don't know who they is, but you can graph a complex number where your x-axis are your real numbers and your y-axis are your imaginary numbers. So for example, if I did this, blimp, 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 this would be 4 plus 5i. Okay, so instead of a comma, you know how a complex number is a real number added to an imaginary number. That's a complex number. So this measures the real number, so over 4 up 5. That's 4 plus 5i. That's how we graph that complex number. Okay, so let's just try a couple more.
Is this a lesson?
Yep. So here's another one. Let's try -2 minus 3i. How do I graph -2 minus 3i? What do I do?
Go to the left.
Left 2 minus 3i. So right there. Remember, this is your I. This is your real number. So this is -2 minus 3i. Does that make sense? So there's no commas. It's just, so you're going to have a positive real number and positive imaginary number over in this quadrant. You're going to have a negative real number and a positive imaginary number over here. You're going to have negative both over here. Then a positive real number, negative imaginary number, just like it is with the other stuff. But this is just a way to graph our complex numbers. Yes.
What are we doing on
Thursday, we're reviewing.
Oh, sorry.
Yeah, so this is not practice test 16 for you guys. I can't remember which one it is. Probably 13.
Because I'm like 16.
Yeah, 13. So that's already uploaded, should be there, ready for you to do it. Okay. All right, so, and then what about this? What if I wanted to graph 1?
What do you mean 1?
Yeah, so this is 1. Okay, because 1 is just 1 plus 0i, right?
Yeah.
So that's how you would graph 1. And then of course you could do just an imaginary number. You could do like -4i. So this is -4i because it's 0 minus 4i. Okay, so you can still graph the real numbers and imaginary numbers separate on this coordinate plane. Okay. All right. Okay, so let me give you a new concept. It's not terribly new, but basically the absolute, we're talking about simplifying complex expressions. All right, so this is all leading up to this. So the absolute value, what's the absolute value of a number? Can anyone remember how to define that? Absolute value.
It's distance from 0.
Yeah, the distance from 0. So it's the same with a complex number. So on this graph, it's basically your distance from the origin. Absolute value of a complex number is basically the distance to the origin. Well, how do you calculate the distance to the origin?
Pythagorean.
Yeah, Pythagorean theorem, right? Or the distance formula. So if I did 4 plus 5i, so the absolute value of 4 plus 5i, I'm going to do it down here. Well, you already know the legs. It's 4 and 5. So it's going to be the square root of 4 squared plus 5 squared, which is 16 plus 25. So that's the square root of 41. Okay? So basically, absolute distance to the origin, so a plus bi is just the square root of a squared plus b squared. Okay? If you forget this, that's okay, because you can just use the Pythagorean theorem to work out that distance. So over here, you can draw a cute little triangle. So that's a 2 by 3 triangle. So to figure out that distance, that hypotenuse of that triangle, just use the Pythagorean theorem, okay? But it's just this number squared plus this number squared, all square rooted, okay? So square root of 4 plus 9, so this is the distance from here to the absolute value of this complex number is the square root of 13, okay? And so negatives don't matter, right? Because when you square it, it all goes away. Okay, so what about this? Well, these guys are easy. You don't have, please don't put this into this formula, but the distance, what's the absolute value of 1?
1.
Just 1. I mean, you could put it in there, 1 squared plus 0 squared, all square rooted. You could do the same thing here. Absolute value of this, of negative 4i, it's just 4. Because it's just 0 squared plus 4 squared, all square rooted. Don't put it in that formula. If it's on one of the axes, then the answer is just right there. Okay, so if it doesn't have the other half of the complex number, the absolute value is just the absolute value of that thing. So negative 4i absolute value is just 4. Absolute value of 1 is just 1. Okay? All right, now, let's multiply complex numbers. It's very similar to just multiplying binomials, foiling it out sometimes, right? So that's easy. So let's start with this example. Let's go example 3a. Let's do negative 4 times 7 plus 3i. We'll just treat that I like a variable. So what's our solution? What is this?
Negative 27 plus negative 29.
Yeah, did you just graphic that? Oh, you multiplied the 7 times the 3 instead of the negative 4. Yeah, just distributing the negative 4, right? So negative 28 plus negative 12i, right?
Oh, yeah, sorry, I didn't mean to.
Yeah, and you could find the absolute value of that, but that would take some work, so we're not going to do that. So let's do 1b. Oh, wait. And that looks different. Ooh, there's a little typo. Oh, no, it's just my eyes stink. Okay, so let's do example 3a2. Because this is how the book really has it, okay? Negative 4i times 7 plus 3i. Okay, well, let's do the first step. What's the first step? Just distribute it. So you get negative 28i minus 12i squared. So far, so good? All right, now I don't know if we talked about this yet, but what's I squared?
You just pause it because like negative it cancels out.
So I squared, remember I equals the square root of negative 1, right?
Yeah.
So what happens when you square a square root?
It cancels out.
So I squared equals -1. It cancels the radical. So that's weird, but it makes sense because that's the only time you're going to get a negative answer when you square something is when you're squaring an imaginary number. Okay? All right, so if that's -1, this is -1, +12. So you got -28i plus 12. See what we did? 12 times -1 is -12, so minus -12 is plus 12. So the better way to write this is the real number first. So 12 and then -28i. Okay? All right, now let's do 3b, the real 3b. So see if you guys can do this one. Okay, you're foiling it out. Anybody have an answer?
I know mine's wrong.
What'd you get?
I got 56 minus 2i.
56 minus 2i. Anybody else?
No, 54. 54. I meant 54.
54 minus 2i.
Yeah, I don't
Okay.
know why I read those.
Are you doing this in your head? How's it going?
Oh, I missed
Pretty
it.
good, actually.
Oh, I never mind. I didn't finish it yet. I just realized something.
Okay.
Okay, this is.
You said 30 plus 8i.
30 plus 8i. Well, let's see. So I'm going to FOIL this out. First thing I'm going to do, 5 times 6 is 30, right? 5 times -2i and -10i. So this is just algebra 1, right?
Mhm.
And then that's a 24i, right? And then you get a -8i squared. So far, so good? Okay, well, we can do a couple things. We can combine our i's, but I'm going to wait on that because I'm going to deal with this guy first. What's -8i squared? +8, right? Because I squared is just -1. So -8 times -1 is +8. So then you've got a, what is that, 14i, and then a 30. So then you can combine these two together. So you get 38 plus 14i. Does that make sense? So unlike a binomial, unlike foiling and multiplying binomials, what ends up happening with complex numbers is you not only combine the middle terms, but you combine the first and last term, because that I squared turns into a real number. Remember, get real, I squared. Clever t-shirt idea. Okay, good, good. All right, so here's what's happening. We know that I equals I, right? Somebody's calling me. It's my wife. Should I answer it?
Yeah.
Yes.
Yeah.
No.
Hello? Hey. No.
Okay.
Okay, fine. Sorry, she just never calls unless there's an emergency, but everything's fine. Good. Okay. So I equals I, obviously. We learned that I squared equals -1, right? So what does I cubed equal?
1.
Not 1. Because this is I times I times
So
I.
just, you know,
Why wouldn't it be
you know,
just one?
you got this one. You got this.
What's I squared again?
It's
Oh,
just-
2. It'd be 2.
No,
-1
no,
Three.
negative one I,
I don't know.
because you have one left over.
I, which is just negative I.
I'm breaking out of the
Okay?
Why wouldn't the last one be a 1? Why wouldn't it be like 1 plus 1? Well, -1
Well, you're not adding anything. It's all multiplication.
or multiplication.
So, but look at this, Gmo. I to the 4th is just what?
1.
1.
1. Yes. So then what's I to the 5th? Well, it's I to the 4th times another I. What's I to the 4th times I? I.
So
One
it's-
I.
So then
One
the
I.
6th is
Positive one I. I don't know.
-1. And it is cycle.
It's just a pattern.
Yes,
Okay.
it's a pattern. It cycles every 4. Okay, so do you see that? Now you could just multiply i's together and figure it out if you forget, but
Okay.
here's what you can remember. Every 4 it cycles. So let's see if you can figure this out. What is I to the 30th?
Can you tell me?
Can you figure it out?
Must be negative
I don't know.
1 times -1.
1?
Yeah, it would, but it's since it cycles every 4, what's the last multiple of 4 before 30?
5. No.
I don't know.
So remember, all the multiples of 4 are 1, right?
Just give up.
So I to the 8th is going to be 1. I to the 12th is going to be 1. I to the 16th is going to be 1. Are you seeing that? Because it cycles every 4 exponents. So see how I to the 5th is just 1 times another I. So that's just I. I to the 6th is just I to the 4th times I squared.
So it's I to the negative, negative I.
So not negative I. But this would be 1 is, it equals 1 whenever there's a multiple of 4, right? So the last multiple of 4 is I to the 28th. So I to the 28th has to equal 1.
So it'd be I squared is -1.
That's right. So this would be -1. Okay? So basically you find the last multiple of 4 exponent. So I to the 28th would be 1. And then the cycle starts over. I to the 29th, I to the 30th, I to the 31st, I to the 32nd. So every 4 exponents, it recycles. Okay? All right. That's just a side note, but this is good to know. So you can kind of do the math. So you could divide this by 4, And if the remainder is 0, then it's 1. If the remainder is 1, then it's I. If the remainder is 2, then it's -1. If the remainder, basically the remainder tells you what it is. If the remainder of 3, it's -I. Okay? But you could just figure it out doing it this way too, but that's just a shortcut. All right? So back to some examples. We did a couple of those already, but let's try this. This is the next one. So we're going to divide complex numbers. So this is example 5. I'm going to divide 3 by 6 plus I radical 5, or radical 5I, okay? Well, let's just do it. Let's see what happens when we do it. So that's just 3 over 6 plus I radical 5. Well, first of all, we can't have a radical in the denominator, and we certainly can't have an imaginary number in the denominator. So how do we get rid of this?
Like, couldn't you do that? Just add a thingy that you have?
Addy thingy? Yep. Remember what that's called?
Box
The
thing.
conjugate, right? 6 minus I radical 5. So the conjugate is basically change that. If it's adding, then change it to subtraction. Whatever you do to the bottom, do to the top. So far, so good?
Yeah, y'all.
All right, so let's do this. What's going to happen is you're going to get 36, and then you're going to get negative 6I radical 5, right? And then you're going to get positive 6I radical 5, which those will cancel. If they don't cancel, then you didn't multiply by the conjugate. That's the benefit of multiplying by the conjugate, is that these confusing middle terms will cancel. And then what's I radical 5 times negative I radical 5? Positive times a negative is negative.
Wait, what's the question?
What's I radical 5 times negative I radical 5?
Well, doesn't radical 5 just equal 5?
Go 5.
Okay, but then the negative I, so it's a negative and
It would be
a
negative
positive, so it's
one.
just negative
No,
I.
1.
Right, so
it's
this-
5.
5I squared.
So you skipped a little bit of a, so this is what we have so far, because radical 5 times, because this is just I radical 5 squared, right?
Yeah.
Well, when you square I, you get I squared. And then when you square radical 5, you just get 5.
Yeah.
Okay? So then, and what's I squared again?
-1.
-1. So this makes this a positive 5. So then you get 36 plus 5 is 41. That's nice. So you got a messy numerator though. You got, what is that? 18 minus 3I radical 5, but all over 41. Okay, now technically, this is okay, but you have to keep your real and imaginary separate, right? So just make 2 fractions out of this. That's it. So this is 18/41 minus 3I radical 5 all over 41. So just keep them separate. Or the better way to write this, 3 radical 5 I. But if you have it like I had it, that's fine. Let's see how I have a real number, and then I have plus or minus something I. So this makes it an obvious something times an I. Okay. Well, let's try one more easy one. So here's 5b. I want to divide this. I want to go 4 plus I divided by 6i. Well, we can't have 6i in the numerator or denominator, right? So how do you get rid of 6i?
Multiply by -6.
If you multiply by -6i, that would get rid of it, but it's overcomplicated because really the only thing breaking rules is the I, right? The 6 is fine. So how do you get real? How do you make that denominator real?
Where, no, however.
You could square it.
Times -6i.
That's what Drew said.
Oh.
So you could do that. That would fix it, but overcomplicated. The only thing that's breaking the rules is that I. How do you make that real?
Well, wouldn't that be a negative?
Just multiply by I.
Oh.
So what does that make that? That makes it 6i squared, which is -6, right?
Times.
And then you got 4i plus I squared. All right?
It's -1 plus 4i.
So -1 plus 4i, that's right. So -1, good job putting it in the right order. All over -6. Okay, let's keep the real and imaginary separate. So -1 divided by -6, 1/6. And then 4 divided by -6 is -2/3. So there's your final answer. Okay, now if you would have done -6i, you would have gotten -24i minus 6i squared all over -36i squared. There's nothing wrong with that. Simplify that, you get -24i plus 6 all over 36. Okay, two separate fractions, you would have gotten 1/6 minus 2/3 I. There's nothing wrong with doing what you guys suggested. It just makes it a little bit more complicated. All right, that is that lesson. Let's move on. Okay, next we're going to solve radical equations. Pretty easy. How do you get rid of radicals? So remember, when you're solving equations, you do the opposite operation. What's the opposite of a radical? Exponents. So if the opposite of a square root radical is you're just going to square it. So to get rid of stuff, you have to do the same opposite to both sides, right? And that does it. That's basically it. Okay, let's try an example right away. So this is a radical equation. Square root of x plus 3 plus 1 equals 4. Okay, so this is a radical equation. This is not a radical equation. X minus square root of 5 equals 8. Okay, because you don't have to get rid of that radical. You can simplify that, whatever, but a radical equation is an equation that has an x inside the radical. Your unknown, your variable that you're trying to solve for is inside the radical, okay? Now, there's some simple steps, but we're going to start with an easier one, actually. Square root of x minus 5 equals 14. All right, so usually when you solve an equation, you kind of do the order of operations backwards, right? Instead of, please excuse my dear Aunt Sally, but Sally and dear my excuse, please, okay? But in this case, you can't do any operation because that variable is trapped inside of a cage. So how do you break out that x? How do you get rid of that cage? What do you do?
Move it.
Square both sides. So this cancels the radical and you're left with x minus 5. And then you just simplify that. Now you've got the easiest equation in the universe. Add 5, x equals 201, you're done. You can just plug it in to make sure that it works. But yes, 201 minus 5 is 196. Square root of 196 is 14. Check, it works. Now here's the deal with radical equations. You have to check it. Because if you don't, you might get a wrong answer. So I'm going to say 201 equals the square root of 196 equals 14. So check. Okay, now let's try something else.
Yeah.
What happens if that radical is not by itself? So here's example 2, or this is example 1b, where you have a radical, 6x plus 7, and then you have another guy over here, and then you have that 9. Because if you square both sides, that's not going to help. If you square both sides right now, you're going to have to FOIL that out. So you're going to end up with more radicals. You're not going to cancel that radical because you're going to have to FOIL that out. And you'll get, if you square both sides, you'll get like 6x plus 7, which got rid of that. But then you'll have 3 times 6x plus 7 plus another 3 times 6x plus 7 plus 9. That's what you'll have on the left side. That doesn't help you at all, right? So what should we do? Well, let me just tell you.
Okay.
So the first step to solving radical equations is instead of getting your variable by itself, you're going to get radical by itself. Okay, and then you square both sides, and then you're home free. Then it's a normal equation. So how do you get the radical by itself? You have to get rid of that plus 3. I know it seems backwards because it seems like you should do that last, but nope, you have to get rid of that 3 first. So then you're left with square root of 6x plus 7 equals 6. Now we can square both sides and it doesn't give us more radicals. So now we're going to square both sides. 6x plus 7 equals 36. Subtract 36, 6x equals 29. X equals 29 sixths, and you're done. Okay, let's make sure that works. Plug it in. So square root of 6 times 29 sixths. Okay, that cancels the 6. So that's square root of 36 plus 3 equals 9. 6 plus 3 equals 9. Check. It works. Okay. All right. Let's and this is just square root radicals. But what if the same rules apply if they're cubic radicals or anything like that? So let's do one like that. So here's example 2. Here's what example 2a says. Cubed root of 4x plus 4 minus 6 equals 0. What do you do first? What do you do first?
Get rid of the -6.
Yeah, so we're going to add 6 to both sides, no problem. So then we get cubed root of 4x plus 4 equals 6. Now what? Cube both sides, right? Cube both sides gets rid of that cubic radical. So you get 4x plus 4 equals 216. Now what? Now we just solve it, right? Now it's just a nice friendly equation. 4x equals 212. Divide by x, and you get 53. All right, so let's just make sure that works. So 4 times 53 plus 4, all cubed rooted, minus 6 equals 0. 4 times 53, we did that. That was 212. So cubed root of 212 plus 4 minus 6 equals 0. Cubed root of 216 minus 6 equals 0. 6 minus 6 equals 0. Check. Okay. All right, so let's, same thing. Let's just add a coefficient. So instead of getting rid of something being added or subtracted, we're just getting rid of something being multiplied. How do you do that? Just divide. Divide by -2, divide by -2. Cubed root of x minus 8 equals -7. Now what? Now what?
Not there yet.
Cube both sides.
Would you
Yeah,
cube
cube
it?
8.
Yeah, but not square it. We're going to cube
Cube
it.
it,
Yep,
yeah.
yep.
Cube it.
Good, good. So we're going to cube it.
Okay.
That cancels, and you get x minus 8 equals -7 cubed. So that's 343. So -343. So add 8 to both sides. X equals -335. Let's plug it in to make sure that works. -335 minus 8 is -343. Cubed root of that is -7. -2 times -7 is +14. Check, it works. Okay. All right. The last few are on a graphing calculator, which is pretty interesting. You can graph these. What these guys look like is they're cubic or square root functions, and cubic root functions are a little bit interesting. So a square root function looks like this. That's the mother square root function. A cubed root function looks like this. Okay. Which kind of makes sense because a square function, a quadratic equation, or something with x squared, that's y equals x squared, and y equals x cubed looks like this. So basically you're inverting, you're reversing the x and the y here, right? So it makes sense that it kind of looks like that, okay? You can try those on your graphing calculator if you want, but those are solving equations containing 2 radical. Oh, well, we're going to do that. Let's do that. Let's do that. Let's do that. Okay, so if you have radicals on both sides, it kind of complicates things. Now, if they're both radicals, you can get rid of them, and it's nice. But if you have a radical plus something or minus something, that makes it more difficult. So 3a looks like this. Square root of 8x minus 15 equals the square root of 4x plus 5. So this isn't bad. All we have to do is square both sides, right? Square both sides and we just get this equation. 8x minus 15 equals 4x plus 5. So 4x equals 20, x equals 5. Check to make sure. 40 minus 15 is 25, square root of 25 is 5. 4 times 5 is 20, plus 5 is 25, square root of 25 is 5. It works. Okay. But what if it looks a little different? What if we have something like this, 3b cubed root of 3x equals 2 times the cubed root of x minus 1? Well, still our only option is to cube both sides. So if we cube both sides, that's going to get rid of this nicely, and you just get 3x. But what's going to happen over here?
2 is going to turn into an 8.
That's right. You're going to get an 8, then x minus 1. Okay? Because that wasn't in a cubed root radical, so you have to do the math. Okay? So then you can distribute, and you're done. So you get 8x minus 8. So you get 5x equals negative 8 or whatever. Blah, 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 blah. X equals, what is that? 8/5. Okay? All right. So the most complicated it will get will look like this. Okay? So if you can understand this, you're doing fine. So here is example 3b. No, 3c. Square root of 2x minus cubed root of negative 5x minus 6 equals 0.
Add the 6 to this other side.
Okay, could, yep, could do that. Let's do that. But let's add, let's put radicals on both sides, okay? So if we do this, if we put like, let's just put this over on the other side. So we get radical 2x minus 6 equals cubed root of negative 5x. See what I did? I just put that cubed root radical over there. Okay? So your first step is if you have two radicals, put one of them, like make sure they're on separate sides. Okay? So if one of them's by itself, then you can eliminate that nicely. Okay? So that's what we'll do. It makes it a little bit more complicated, but we could do it this way. Yeah. So now we cube both sides and we get square root of 2x minus 6 cubed equals negative 5x. That's what happens when you cube both sides. But then you have to deal with this mess, don't you? So then when you do that, you can use the binomial theorem and get down. But what they did in the book, I didn't see this, was they used the graphing calculator and they figured it out. But more practically, there's like other situations where you'll have two square root radicals. So put them both on both sides and then square both sides, and then you'll have to FOIL one out, and then you'll have to get that radical by itself. I don't think we have any of those in this example, so I'm not going to worry about that. So don't worry about this problem. If you want to solve it with a graphing calculator, you can, but if you get to those, don't stress about it. There won't be those on the test. Okay, this is example 4, and this is what we need to talk about before we quit. We're going to talk about extraneous solutions. Okay. So let's just do another example. Square root of x minus 4 equals negative 8. Okay. Back to the basics. How do we solve this equation?
Add 4.
Add 4, add 4. Square root of x equals negative 4. Square both sides, right?
Yeah.
x equals 16. When you plug in 16, you get 4, right? What's 4 minus 4? What's 4 minus 4? 0. So square root of 16 minus 4 equals -8? No. Here's what's happening. Because technically, what's the square root of 16? 4 and -4. -4 minus 4 is -8. But in algebra, if you just have this, your only responsibility is to give the positive solution. Okay? So this cannot have two solutions. So we call this an extraneous solution because it doesn't work when you check it. If it doesn't work when you check it, it's still a solution, but we call it an extraneous solution. Okay? Okay, so we'll do one more example and then we'll be done for the day. So here's example 4b. Let's try this one. You can try this on your own. X plus 1 equals the square root of 2x plus 10. So let's solve this equation. Go, go, go.
Wouldn't you want to move the x over first?
So the first step in radical equations is to get the radical by itself, which it is, and then square both sides.
Yeah.
So you can't solve for x yet because one of the x's is trapped inside of that radical. So before it's a normal equation, you have to get rid of that radical. So it gets interesting real quick because when you square that left side, what happens?
The x becomes square root of 1.
Yeah, you get a FOIL problem, right?
Yeah.
Okay, and so then you have this situation. You have to solve a quadratic equation. So I'm going to get there. X plus 1 squared equals 2x plus 10. Square that. Remember, it's not x squared plus 1. It's x plus 1 times another x plus 1. So you get x squared plus 2x plus 1. So this is nice. Whenever you have the same term on both sides, what can you do?
Cancel.
Cancel. So then let's see. I'm going to bring this 10 over there. So x squared minus 9 equals 0. Or you could bring that 1 over there and you get x squared equals 9. So what's x? Or you could factor that difference of two squares, x plus 3x minus 3, so x would be 3 and -3. So now we have to test each one, right? So let's test them. So what happens when 3 is in there? X plus 1 equals square root of 2 times 3 plus 10. So x plus 1, oops,
Yeah.
it's 3 there, equals the square root of 16. So 4 equals 4, check. Let's plug in -3. -3 plus 1 equals square root of 2 times -3 plus 10. So that's -2 equals the square root of +4. -2 equals 2? No. So you've got two solutions, but this one is extraneous. Okay, so your answer would just be the solutions of -3 is extraneous. The only solution, real solution, is just 3. Okay. So if it says list the extraneous solutions, you can. Otherwise, your solution is just 3. Okay. But they do. It's technically a solution. It's just called an extraneous solution. But if you're asked to solve this, your solution would be 3. Okay. Questions? All right. That's it. Well done.
Black math, give me some math and I'll give you some flack. Black math.